Page 168, do review numbers 1 through 7. Yeah, I'll keep that thought in mind. Page 168, review 1 through 7, the odd. And turn your books to page 168. Some of you there, some of you not. Page 168, just those 4 problems. Just a quick review of things that we had talked about last semester, some basic equation concepts. And number 1, what type of equation is that? Brandon?
Conditional.
Conditional equation, and your answer?
X equals negative 1/3.
Negative 1/3. Pretty straightforward. Whereas number 3, what kind of equation do we have there, Abby?
I thought it was conditional.
It is also conditional. Good. And what do we get for our answer?
Y equals 0.
Y equals 0 is our answer. Good. How many got both of those correct? Just want to make sure you thought it through. All right, number 5, an absolute value equation. Again, isolate the absolute value, set equal to positive, negative, and what did we get for our answers here, Audrey?
11 and negative 1.
11 and negative 1 is correct. How many had both of those correct? Excellent. And the number 7, a literal equation. Again, the key here is going to be to factor out the x and then maybe factor the other side as well. What do we end up with for our solution here? Michael?
X equals a negative 3.
X equals a negative 3. You might specify that a cannot equal negative 3, therefore x cannot equal negative 6, but at least have x equals a negative 3. How many had that for number 7? All right, any questions on the very short homework assignment that you had last night? All right, let's go and review some things we talked about. If you're watching on YouTube, I encourage you to have a straight edge available. Also, if you have highlighters or different colored pens, that kind of thing, again, this is a section where that's going to be helpful for you. I finally remembered to bring different colors of chalk, so we'll be able to do that as well. But more colors is helpful, and this is where, for the first time, ladies, you're not being criticized for having 17 colors of pens.
Ladies.
And Brandon, apparently, who also has 17 colors. Sorry, stereotypically, it's always the ladies who have all the multicolored pens. He's like, yeah, all I've got is black. All I've got is black. Nothing but black. Sorry, didn't mean to target you there, Brandon. Didn't see that one coming. The key is just be quiet when I say things like that. Anyway. Some things we talked about yesterday. We got into graphing, and we said when we graph, we draw a couple of number lines. But these 2 number lines, how do I draw them, Maddie?
Up and down, side to side.
Good, up and down, side to side. We could say perpendicular if we wanted to sound really, really educated. Perpendicular to each other, but your description is no less accurate than my own. And these number lines have a new name once we arrange them perpendicular to each other and put them on graph paper. We call these number lines? Axes. Very good. Now, which axis is which? Michael?
The x-axis goes side to side, and the y goes up and down.
Good. Or if we want to sound a little more educated, we might say the x-axis is the horizontal axis, and the y-axis is the vertical axis. Of course, not everyone understands vertical and horizontal, so maybe it is easier to say side to side x and up and down is y. But anyway, these 2 axes intersect at a point called the origin. And what is the value of the origin on each axis? Don't overthink this now. Brandon? 0. It is 0 on the x and it's 0 on the y. It's the 0 of both of them. These 2 intersecting axes form 4 sections on the graph grid, and those 4 sections are called, back to Audrey for redemption,
Quadrants.
Quadrants, very good. And which quadrant is the first quadrant? Use top, bottom, left, right as your directions there.
The right, top right.
I'm trying to see if she understands left and right. She does. Top right. Excellent job. Top right quadrant is the first quadrant. And again, remember, it's going to go around the letter C. So first quadrant, second quadrant, third quadrant, fourth quadrant. Or I could cheat and come over here and get the poster in there. So we got our first quadrant, second quadrant, third quadrant, fourth quadrant. Also, the x-axis is the horizontal, y-axis vertical. Anyway, all that fun stuff there. Now we see, of course, on the poster here, we've got in parentheses the positives and negatives and stuff separated by the commas. The first value in the set of parentheses is always which value, the x or the y, class? X. That makes sense. Alphabetically, we put the x value first. The second value, of course, is the y value. What's the name for the x value of a point, Maddie?
It's not the abscissa.
It is the abscissa. Yep, it's that one. The abscissa is the x value for the point. Now, the y value is the other one. Do you remember the other one?
Coordinate. No.
Close.
No,
not Paul. Take off the C sound. Class.
Ordinate.
Ordinate. The ordinate. You said coordinate, just the ordinate. What are coordinates? Yeah, anyway. The cough had nothing to do with the answer. It was just a cough.
It's an off now.
Don't cough during the next test or quiz. You can be like, cough. I remember that being a term. No, let's take cross off the C. O-U-T-H? Oh, man. Kendall, I asked a question a minute ago, and it was, what are coordinates? She said coordinate. I said, no, it's just ordinate. What's coordinate? Oh, Canissus is here. We gotta be quiet. No fun. Speaking of no fun, I put you right in front of Michael. I'm sorry. Somebody had to sit there.
Okay.
I sit next to
She
him.
gets screwed up.
Sadly. It's a pretty sad world. As she solemnly sits down, tears flowing from her eyes. We're back to Kendall. We're going to try this again. What are coordinates? And so, more, you might say it's the, somebody help her.
The abscissa and
What?
It's like the location.
Okay, it's the exact location of the point, which is kind of what she said. It's the abscissa and the ordinate together. So it is the collective point in the parentheses with the comma between them. It's the x and the y together is the coordinates. So just the x value class is the abscissa. Just the y value is the ordinate. And you put them together, you have coordinates. You put them together in parentheses. Coordinates. Not cough, coordinates. Now, Kendall used a term a moment ago. This is going to be my next question. And this whole thing on the graph paper with the axes with their arrowheads at the ends, and vertical and horizontal, and the four quadrants and all of that is on a flat surface where we'll do our graphing. And that flat surface with the axes and stuff is called the Cartesian plane. Good. Now, yesterday we looked not only at plotting points on the Cartesian plane, we also looked at graphing straight lines. And we said, what kind of equation will graph as a straight line, Abby?
Linear.
A linear equation. And so we said to spot a linear equation, for instance, x, let me drag the screen back over here, x minus 3y equals 4. I can tell by looking at this that it's going to be a straight line. I can tell by looking at it that it's a linear equation. How do I tell just by looking at it that it must be linear, Audrey?
Because to the first power.
The x's and y's are both to the first power. Now you need an x and a y preferably in order to graph that. So we've got the x and the y, and they're both to the first power. That's a linear equation. It's going to graph as a straight line. Same thing would be true if I had something like 6 minus 3x equals y. Okay, that's a linear equation. It's going to graph as a straight line. And yesterday we talked about two different ways to graph linear equations. Now neither of them are perfect. Neither of them are ideal. But they kind of progress toward where we're going later, and what we ended up at in Algebra 1 last year. The first method of graphing we talked about, anyone, was the table method. Now the upside of the table method is this can work with weird equations too. Even if they have weird powers, you can always go with an XY table. But the key to using an XY table to graph is you have to get a letter class by itself. You've got to get a letter by itself. Right now we don't have a letter by itself. What might we do to this equation, Genesis, to get a letter by itself?
Get rid of something.
Sure, what might we get rid of?
-3.
I'd get rid of the whole negative 3y. Because that would get x by itself, right? The whole negative 3y just poof, gone. But I don't necessarily poof, gone. What do I do to get rid of the negative 3y? There we go. So the x by itself is equal to... There we go, and now x is by itself. Now it's important to remember, as we set up our t-chart, our xy table, we're going to plug in values for which letter, x or y here, class?
Y.
Is it always that we plug in for y? No, we always plug in for the letter that is independent, not by itself. So x is by itself, that's what we're going to solve for. That's the dependent variable, you might recall. Of course, these are constants. The y is the independent variable. And I like easy numbers. Easy numbers like 0 and 1 and 2. I like plugging in easy numbers. Make sure you put it in the correct column. It is y. And when we plug in a 0 for y, What value is x going to be, class? 4. What if I plug in a 1 for the y? What's x? 7. Brandon's doing great with this. How about the rest of you? Plug in a 2 in for the y, class. We get 10. And so I get 3 points. That was my point of emphasis there. We want 3. Why 3 again, Michael?
Because 3 gives you a check.
Good. 3 gives you a check. If all 3 points line up, you know you did it right. That or you were consistently wrong. But more than likely, you're consistently right. You've made it this far in your math career, if you want to call it that. So probably these 3 points. Again, if we wanted to, we could separate them like this. I'm usually too lazy to even do that. I know it means 4, 0, 7, 1, and 10, 2. By the way, all 3 points will end up in what quadrant, class? First quadrant. Because remember, the first quadrant is positive x's and positive y's. So we know we're going to be in the first quadrant for all of these points. Though the line, remember, that we get from our linear equation will extend indefinitely. And we'll go into another quadrant or 2 or 3 as well. So we plot our points. We got 4, 0. Remember, over 4 up nothing. We have 7, 1 over 7 up 1. And then a 10, 2 over 10 and up 2. It would help before I did all of this if I actually put the arrowheads. Remember, and you'll do this on every graded graph that you do. Otherwise, you'll lose points. You'll put x at the positive infinity end of the x-axis. You'll put a y at the positive infinity end of the y-axis. And you put increments on the graph. You'll label below the x-axis, just like you've always done on a number line, remembering that this here, class, is 0. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If it goes out that far, backward, of course, would be negative 3, negative 6, and so forth. The y-axis, do I go to the left or the right with the numbers? I'll go to the left to keep that first quadrant empty. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. Down as well into negative, going down toward negative infinity. Put those increments on there. You could label every 1, but remember I said it takes forever. I'm too lazy. Every 2, I'm too lazy even for that. 3 is kind of my perfect number I found. And it really helps to have a straight edge, as I mentioned at the beginning. So get your straight edge and line up the 3 points. If they don't line up, something's wrong. At least one of the points is incorrect. And draw the line. When you draw the line, you want to not just connect these 3 points, because this isn't a line segment. You want to draw pretty much from edge to edge of the graph. Some people would argue you should put the arrowheads on the ends. I'm usually too lazy for that, though it's not a bad thing to do. But as long as you're drawing edge to edge, it should be fine. I did comment that where a line is drawn, it will usually cross the x-axis once and the y-axis once. What do we call these points where the axes are crossed by the graph? Maddie? Intercepts, good. So this here, class, we would call specifically the x-intercept, and this here would be the y-intercept, because it crosses the x and the y-axis. And I said we could actually use the intercepts, just those 2 points, to get a straight line using another method. So for instance, for this, yes, the y is by itself, so an xy table probably would work, but it may be even faster to find the x and y intercepts. The key to an intercept, well, if it's crossing an axis, it's crossing a 0 value, right? Anything that crosses along here has a y value of 0. So all of your x-intercepts for any graph you ever draw will always have a y-intercept of 0. And for that matter, anywhere a line crosses here has an x value of 0. So your y-intercept will always have an x value of 0. And if you plug in a 0 for the y, 6 minus 3x equals 0. Let's move that negative 3x over, class, as a positive to get 6 equals 3x. Obviously, x is 2. And if I plug a 0 in for the x, well, that's really easy. It says 6 equals y. So what's y? 6. And there's my 2 intercepts. And again, since you're so unlikely to mess up a 0, the negatives could complicate things, put your 2, 0, your 0, 6, and you connect the dots. And that's a pretty quick, easy method. Now, as we looked at yesterday, sometimes you get fractional intercepts, and those are really annoying. But nonetheless, we get those, and we draw our line, and there we go. Questions on this? This is all we talked about yesterday. Questions on this? Make sure you're studying over a lot of terms, Genesis. I pointed out in yesterday's lesson, a lot of terms to keep up with. Another thing we talked about yesterday, as I drew these lines, is we noticed that this line is kind of slanty this way, this line slants differently. In fact, they almost look like they're perpendicular to each other. But anyway, I'm not sure if they are. They are perpendicular to each other. But these lines have different slants. But we don't use the term slant in math. We use the term slope. And this is kind of where we left off yesterday, was talking about slope. By the way, what letter do we use to represent slope? And don't think about the word at all, because it makes no sense. Kendall? M. Why M? No idea. But anyway, M is used to notate slope. And we said slope is actually defined as a fraction. Something over something. Class? Rise over run. Where we said that rise refers to what kind of movement, class? Vertical. And run refers to what kind of movement? Horizontal. Up and sideways, whatever. Okay. So since up, or vertical, is the y-axis, rise refers to some change. Remember that delta indicates change in the y value. And run indicates some horizontal change or a change in the x value. So this kind of is our equation, if you will, for slope. So as I look at this equation here, I notice that this line goes up 1 and then over 3. Up 1 over 3. And of course, that's going to continue up 1 over 3, up 1 over 3 the whole time, because it's a straight line. So that slope is going to remain constant. We could say that this line has a slope of rise 1, and the run goes in the positive direction, run of positive 3, or a slope of 1/3. For this line here, if I just took these 2 points, for instance, I go up 6, and then I go backward 2. So here the slope would be rise 6, go backward 2, or I could reduce 6 over -2 to what? -3. So you say this line has a slope of -3. Questions on slope? Questions on that? I got a handout for you, not to insult your intelligence at all. By the way, this handout, we're not going to do much with it today, but I need you to keep it, and because we're going to be using it in the next couple of lessons. For the first 3 problems on the handout, obviously if you're watching on YouTube, as you well know, it'll be in the description of the video. But numbers 1, 2, and 3, I want you to figure the slope of each of these lines. Track the slope of each of these lines. Obviously, number 1, they help you out a little bit because they give you some points on the graph. 2 and 3, you're going to have to figure out some points on the graph you can use to find the slopes, to find the change in y or the rise, and then the run. Remember, a backward run is negative. Take just a couple minutes. Or maybe a minute. Again, your answer should be a fraction because you're finding a rise and then a run. Well, it looks like I've got one right there. You see that? Looks like it goes right to a dot. That doesn't look like a dot.
I don't see the dot.
Okay, so you're looking where these lines cross the other lines. Looks like right here, that's perfectly on the 2 lines, right? So that's what you're going to have to look for, is find a spot where it perfectly goes through the lines, and find at least one more spot where it perfectly goes through the lines. Figure how much does it rise from the lower point to the higher point, and then how much does it run either positively or negatively. Take about 30 seconds more to work on these problems. let's go ahead and take a look at these together. Number one should have been really straightforward because they gave you some points. I'm going to go with just the positive points because negatives are annoying, okay? So I'm going to start at 1, 0, and I'm going to look at the 4, 2. How high does it rise, class? 2. That's your rise. How far does it run? 3. Now, is that positive or negative run? It's positive. So my slope is 2/3. Really straightforward. Number 2, you had to find a point. And as I look at it, I see a perfect point it looks like at 2, 1. Do y'all see that? Now, you might have used a different point, but I see a nice easy point right at 2, 1. Looks like a negative 2, 4. I see another nice clear point. See that? Negative 2, 4. All right, so if I just go off of those, what's the rise from 2, 1 to negative 2, 4? 3. Rise of 3, what's the run? 4, but backwards, so negative 4. So 3 over negative 4, obviously the slope is, class? Negative 3/4. All right, and then number 3, I see a nice clear point at 3, 2. And I see another nice clear point at, looks like 5, 3. For that matter, 1, 1. I've got a nice clear point. Okay, so let's just go with 1, 1 and 3, 2. I got 1, 1 and 3, 2. What's the rise? 1. And what's the run? 2. Positive or negative? Positive. So what's the slope? 1/2. How many had all 3 of those correct? Questions on that? Don't make this hard. Right? Slope pretty easy. Just got to find 2 points. How high does it rise? How far does it run? Whichever direction, positive or negative. Now, as we look at slope, then there are actually 4 kinds of slope. 4 kinds of slope. Obviously, 2 of our slopes that we got were positive fractions, and 1 of our slopes was a negative fraction. Well, what makes slope positive is that the line goes up and then runs forward. So any line that has a slope like this has positive slope. It could be like this, but as long as it appears to be, as we read from left to right, it appears to be going up, that's positive. A line that goes up and then goes backward in its run would slant this way. Now, as we read from left to right, it appears to be going downward, right? So that might make it easier to remember negative slope. It looks like it's going downward. Really, it's up and backward, but any line, this line, this line, this line, this line, this line, any line like this that appears to be going downward from left to right has negative slope. But technically, they both rise, they just run opposite directions. But what if a line never rises? It just runs. Never goes up, it just goes and goes and goes. Well, then it would be perfectly horizontal, wouldn't it? Perfectly horizontal line has no rise, only run. How do we say no rise? Mathematically, nothing is 0. 0 over anything, class, equals 0. So a perfectly horizontal line has no slope. Practically speaking, the floor of a building should have no slope, correct? So if I were to be walking down the hallway and I suddenly trip and fall on my face, after I get up and you're laughing at me, I can't be like, man, the slope got me again. There is no slope, right? Maybe you're going uphill, you slip and fall. Okay, people understand. Going downhill, slip and fall, you're going to be rolling a while, but people understand. People don't understand because there is no slope. There's 0 slope. This isn't sloped. Agreed? So sometimes students get confused. What is the slope? None! Okay? No slope. Level ground, right? What every runner wishes he could have. How many of you run occasionally for exercise or whatever? I did in high school. I'm old and fat and out of shape now. But when I was in high school, I did a lot of running. I loved level ground. I hated hills. But what about this? What about a line that rises and never runs, like the sheer wall of a cliff? Is there slope there? Well, I mean, if you fell off the edge of it, you would definitely have to agree there's a whole lot of slope. It's even worse than this. It's more negative than this, right? You slip going uphill, probably catch yourself. Slip going downhill, you roll a while. Slip off the edge of that. As you're crashing to your death, you're going to have a really hard time defining exactly how much slope, but there's definitely a whole lot. In fact, one could argue there's infinite slope. But infinity is impossible to define, so we refer to this slope as undefined slope. Realize here then, you've got some rise, however much, but 0 run. Well, you can't have a 0 denominator, and we know that, right? 0 denominators are no good. It's impossible to define, so a vertical line has undefined slope. Okay, these are the 2 that students get backwards. Which one is 0, which one is undefined? Well, one isn't sloped at all. The other will kill you, okay? So however you want to remember, these are our 4 general kinds of slope. And of course, within positive, as I said, there's a whole litany of different angles of positive slope, if you will. There's a whole bunch of different angles of negative slope, but anything that appears to be going up, that is up and to the right, is positive. Anything that appears to go down, or technically up and to the left, is negative. Questions on the 4 kinds of slope? All right, so turn your textbooks, if you would, now to page 158. Page 158. We've been on page 168 a moment ago. Page 158, this is really not, don't make this hard now. We're simply going to say, is the slope positive, negative, 0, or undefined? Okay, we're going to answer this as a class. You don't want to be the one who answers wrong and looks stupid. Or the person who doesn't answer at all and looks like a sloth. Number 13, what kind of slope do we have, class? 0. It isn't sloped at all. It's perfectly level, horizontal. Number 14, class? Undefined. It's sheer cliff. Number 15. It is almost sheer cliff, but it is going downward rapidly. Or you could say up and to the left. From your perspective, up and to the left, which would be negative slope. How about number 16? 0 again. Number 17? Undefined again. Number 18? Positive. It appears to be going upward or up and to the right. Number 19? Negative. Appears to be going downward or up and to the left. And then number 20? Positive. Very steep positive slope, but still positive slope, not undefined. Do we understand the 4 kinds of slope? Good. Now, how are we going to use slope? Well, where we left off in the notes yesterday, we were talking about graphing linear equations. And we said we can use the table method. It takes a little while. It's annoying. Point-by-point graphing is just annoying. We talked about the intercept method, but if it gives us weird fractions, that's kind of obnoxious. Method number 3, and you should already have this in your notes, Roman numeral 3 was slope-intercept form. Find where that was in your notes. And if you didn't leave yourself room, maybe pick up Roman numeral 3 wherever you left off. Roman numeral 3, let's talk about graphing using slope-intercept form. When we talk about form refers to the way something looks. For instance, those who had me in PE know, one of the things I like to work on is form for different things. Form in running, right? Don't want your head waving all over the place. Don't want your arms crossing the midline of the body or your feet like kicking out sideways. That's bad running form. Volleyball, right? There's a proper form for when you're bumping or setting. There's all kinds of different form you have to use, even for kicking a soccer ball. Where does your plant foot go if you're going to get the proper power on it? All kinds of things form. Form refers to the way something looks, right? Slope-intercept form refers to the way an equation looks. Now, we're talking about linear equations, so we already know one of the things that has to be true, x to the first and y to the first. But the form or the layout or the look of the equation is going to fall into this basic layout, right? Just in your notes and memorize it. Y equals mx plus b. Most of you should vaguely remember learning this at some point. Y equals mx plus b. Key is this. Y is by itself, then your equal sign, then the x term will probably have a coefficient with it, then your constant term last. Let me say that again. M and B are simply numbers, okay? M, of course, we already know what that means, class. Slope. And from the name, slope-intercept form. Anyone want to hazard a guess what the B means? Intercept. Specifically the y-intercept. Okay, so the B indicates the y-intercept. By the way, that almost seems as random as M for slope, except you can't use y for y-intercept because y is already here. A is x-intercept, B is y-intercept. You'll get to that later on in math. For now, all we care about is the y-intercept, and we represent it with B. So for instance, if I had y is equal to, toss me out a number, 7, x, and then give me another number.
4. 42.
6.
Negative 42. All right, whatever, okay? Some random number. Do you see the y is by itself, then the equal sign, then the x term, then the constant at the end. That's slope-intercept form. And just looking at this equation, which I'm glad I don't have to graph, I can tell by looking at it, the slope is 7, the y-intercept is negative 42, which is why I'm really glad we don't have to graph this, because I wouldn't want to have to graph all the way down to negative 42 for my y-intercept. But the slope-intercept form of an equation, if we can get an equation in this form, I literally do no math. I just graph it. For instance, write this equation down in your notes if you would, please. Y equals 4/3 x, negative 2. y equals 4/3 x, negative 2. If you would also set up a Cartesian plane on your graph paper. Genesis, do you have graph paper? Not bringing it today. Someone have an extra sheet they can run, Genesis? Thank you, Maddie. And others who volunteered, but Maddie was the first one handed. Remember, arrowheads at the ends of the axes, x and y labels, and then increments every however many you want, though again, I wouldn't do more than 4 apart, because then it gets hard to locate where points are. As we graph in slope-intercept form, really 3 easy steps. Step number 1, plot the y-intercept. Now, some students struggle like, what does that mean? Plot the y-intercept. Well, you have to understand what an intercept means. Again, if you get behind on notes, you're floundering. So what is an intercept, class? It's a place where the graph crosses an axis. Right? Well, the graph is the line. It's where a line or the graph crosses the axes. And if it's a y-intercept class, then this is where the graph crosses the y-axis. So the y-intercept is a point on the y-axis. Does that make sense? Now, looking at this equation, y equals 4/3 x minus 2, what is the y-intercept class? Negative 2. The plus b, the constant at the end, is the y-intercept. And that's what you're going to graph first. I'm going to come to my y-axis, and I'm going to find negative 2, put a point there. With or without the sound effect. Actually, without the sound effects would be best. Be really obnoxious during like a quiz or something. All over the classroom. So anyway, put a point at negative 2. That's your y-intercept. So that's step 1. Couldn't be easier. Step number 2. Track the slope. Track the slope. Now, slope, remember, is a fraction. Slope is what over what, class? Rise over run. In this equation, remember, the slope always comes in front of the x. It's the coefficient of the x. Well, here the coefficient is 4/3, so obviously the slope is 4/3, which means I'm going to rise how much and run how much? 3. From where? From the y-intercept. So you plot that first, and then once you go, you rise 4, and you run positive 3. And then put another dot. Easy enough. Y-intercept, rise, run. And then, since we know 2 points determine a straight line, step number 3, you get to play connect the dots. Somebody was commenting on going back to first grade earlier. There we go. And there's our line. And we didn't have to do any math. Isn't that wonderful? I love not having to do math. It's like I'm getting paid to do nothing. It's great. Ultimate laziness. How many, as I go over this, I remember this from Algebra 1. How many are like, no, definitely not. Do not remember this. We're going to do a few more anyway. All right, so write this one down. Y equals negative 2/3 x plus 1. And let's see, I'll go with pink chalk for this. All right, the equation is in slope-intercept form. And slope-intercept form, there's 2 things, the slope and the intercept. Which one do I plot first? Start with the intercept. I know we call it slope-intercept form, but you're going to start with the intercept before you track slope. What is the intercept in my equation, Genesis?
1.
The positive 1. So we're going to start with positive 1. And again, it is a y-intercept. So that means, class, I'm going to find the 1 on the y-axis. Seems like every year I get a kid who tries to put it on the x-axis. It's the y-intercept. So we're not going to, I don't care about this one. That's an x-intercept. Y-intercept, right here. Positive 1. From there, we now track the slope. We're going to rise, well, first of all, what is my slope? Michael?
Negative 2/3.
Negative 2/3, which means I'm going to rise how much, Michael?
2.
2. Then I'm going to run how much? Careful, Michael.
Negative 3.
Negative 3. Put another dot. And then, class, we just connect connect the dots. Which without a straight edge is very hard. With a straight edge is very easy. So have a straight edge. I do sell straight edges for $1. I just don't have any with me today, so you have to tell me after class if you need one. Connect the dots. Boom. We have line. Easy enough? I'm going to insult your intelligence a little more. Let's do another one. Y equals 3x plus 1. Y equals 3x plus 1. Let me make sure I'm not getting off the camera here. Once again, we want to graph the equation. We've got y equals x term, 3x, constant, positive 1. But we're going to start class by plotting the y-intercept. Where is the y-intercept, Maddie? The positive 1 again. So it's actually right on top of my last y-intercept as I now go with the yellow. Then I've got to track the slope. But Kendall, what's the slope? 3. But remember, class, we said slope's a fraction. It's rise over run. 3 ain't a fraction. This is one of the rare times in math that you want a fraction. And if it ain't a fraction, you got to make it a fraction. How do I make 3 a fraction, Kendall?
1.
Over 1. So therefore, Kendall, once I've plotted my y-intercept at positive 1, I'm going to rise
3.
and run
1.
which direction?
Right.
Right, forward positively, correct? We're going to run right here, and then all we have to do to finish class, connect the dots. I'm not sure how different that shows up on the camera or not, but that is yellow, not white. All right, questions on that one? Seem pretty easy. How many feel like I got this? All right, do the next one on your own. Go with another color, or maybe go with a dotted line if you've already used up all your colors, like I did by accident. Y equals negative 5x, negative 4. Y equals negative 5x, negative 4. Graph it on your paper, on your graph, your Cartesian plane. A great section for those who have highlighters and multiple colors of ink, regardless of whether you're male or female. Is that better?
Yes.
Okay, good, good.
Very much.
He was offended earlier because it said, ladies, you have all those different colors of pens. Now's the time to use them. He's like, ladies? Oh, poor Brandon. And if you have a pen that like has like the little slots thingies you push down and changes colors? Or anyone had one of those at one point in your life?
Mm-hmm.
Yeah. Those were so cool when I was in 3rd grade.
all down at the same time? Yes.
They don't all go down at the same time, though. Not unless you open up your pen. You still try, yes. Of course, every kid. Gavin's like, I cut off the end of my pen so I could put all 4 of them down at once. I wouldn't doubt it. So looks like Brandon's going with the red here. All right, Brandon, so what do we do? Walk me through.
Y-intercept at -1.
Which would be down here. I'm going to have to go white again here. All right?
And then you have to make -5 a fraction over 1. And so then you go up 5.
1, 2, 3, 4, 5.
And then -1, so to the left 1.
1. Then what?
Connect dots.
Good. And how many got a line just like this, except maybe you didn't have to go dotted because you had a red pen that you could use? How many a line like that? Good. We all good with slope-intercept form and graphing? And is this easier than the intercept method and table method? Yeah, I like it because I'm lazy. Turning page. All right, got 3 more for you to do on your own. I want a new Cartesian plane though. So set up a new Cartesian plane to practice with 3 more of them. Y equals a half x plus 3. Y equals 5/3 x minus 7. Sound cool too, Brandon. And y equals negative 3x plus 1. What can I say? You never disappoint. You're a fantastic student, Brandon. I need someone to pick on it. Man, here I am. Thank you, Brandon. I appreciate it. And you gave me Reese's for Christmas.
I gave you one.
I think I ate it the other day. There was one that was slightly smashed. I think it was from being smashed in my stocking. So, but it still tasted great.
They have no respect for Reese's.
Some people. I have a great deal of respect for Reese's, though, Abby. Abby is finished. Kendall's finished. Audrey's finished. Michael's finished. Randall is finished. Genesis is finished. Dramatic stares. Maddie's finished. Nice dramatic pen click there at the end too. All right, I like that. Nice touch. All right. So for the first one, Maddie, what did we do?
Okay, put a dot thingy over 3.
Which 3?
And then the top one. Then go and it goes like this. Yeah.
The y-axis. 3.
Go 1 into the right 2. And then connect it.
Good. Rise 1, run 2, connect dots, and you should have had a line that looks like this. Everyone had a line like this? See? Yeah?
Yeah.
I don't know how to say yes in other languages, so we'll go with that. All right, what about the next one? Genesis.
Put a dot on the -7
Which one?
on the y axis.
Very good.
And that's 5.
Okay.
And over 3 positive.
Okay. There's a commercial for, I think it's Farmers Insurance or something like that. I don't know if you know the one I'm talking about. The lady's like, she needs a watering can. And she's like, hey, do you have that thing that's kind of like a teapot but for plants? And the lady's like, huh? You know, like that gives the plants water? You mean a hose? No, the thing's like a boo 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 boo. It like gives the plants a shower. Oh, a watering can. Yeah, that's what I meant. I was like, you're good at describing things when you forget words. We're good at your insurance. Farmers, anyway, something like that. That's what I thought of it. Anyway, it's like, the thing's like, boo 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 boo. Watering can. Yeah. All right, great job, Genesis. Great. All right, and then the last one here, Audrey.
You put a dot on the y-axis.
Where?
That line.
What?
That line, the y-axis.
Yeah, but where on the y-axis do I put my dot?
On 1.
On 1. Okay.
And then you run. No, you rise 3, and then you run backwards 1.
Good, run backwards 1 this time. Now, I will point this out, and some students watching may be thinking, couldn't you go down and over? you could, especially if your intercept was up here. Instead of rising, you could rise negatively or go down, but you have to remember that the run also changes direction. So for instance, if instead of going up 3, we're like, no, I'm going to go down 3, 1, 2, 3, we've already used the negative. So don't then run negatively. Now you have to run positively, and you can see all 3 points would line up. Again, my preference would be to always rise and then run positive, negative, but yes, you can reverse the process, particularly if your y-intercept is up high on the grid and you don't want to extend it and make it bigger. You can always go backwards as well. How many had lines that looked like these 3? All right, any questions at all on slope-intercept form for what we talked about today? All right, tonight your homework has nothing whatsoever to do with this. Your homework is some more review from the last semester. Page 158. Page 158, review 1 to 7 odd. Page 158, review 1 through 7 odd. It gives you some practice on some of the last things we talked about before the semester exam. Do, however, study over terms, notes, all the stuff we talked about yesterday and today. Make sure you study. Also, make sure the handout that I gave you, don't lose it. Bring it back tomorrow because you're going to need it for tomorrow's lesson. So bring the handout back. So 3 things. Review 1 to 7 odd on page 158. Study your terms in your notes. Bring the handout that I gave you. Bring it back tomorrow. Ideally, don't write on it or fold it or crease it because then I can't use it again next year and lazy me doesn't want to print more of these. All right. Anyway, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.
We weren't supposed